Don't you hate it when you're on a nice leisurely drive with your family and the ground starts shaking and all of a sudden your car falls down to the center of the earth? Well, that's what this video is about. In this video, we're going to talk about stress, brittle deformation, and faults. Now, why are we going to talk about it? Because all of this is leading up to earthquakes, which is our ultimate goal by the end of the week. So during the video, we got to learn what the three types of stress are. We have to know what brittle deformation is. You should know what a fracture versus a fault is. Know what the hanging wall versus the footwall is, which is really important when it comes to identifying the three types of faults. Okay, so I had this little hockey duck here, generously donated by my daughter. And if we take a look, there's a few things I can do to this duck if I want to stress it, or if I want to apply a force, because that's all stress is when you apply a force. I can squeeze it, and if you notice when I squeeze it, it all compresses together. This squeezing force is called compressional stress, because I squeeze it together. I can apply tensional stress to it, which means I'm pulling it apart. I'm pulling it in opposite directions. One hand's pulling out this way, the other hand's pulling out this way, and this is tensional stress. I can pull it all apart. And the third type is I'm going to push the head down, pull the body up this way. Third type is called shear stress, where I'm pulling this in opposite directions. This guy's pulling up, this guy's pulling down. This is called shearing or shear stress, opposite directions. So what does that look like? Here we go. First of all, stress. Here's your vocab word. You should write this down. Stress is any force applied to strata. Now again, if you don't remember, strata simply means layers of rocks. The implication here is we're not talking about one rock. We're not talking about two rocks. We're talking about entire layers of rocks that are within the earth, close to the surface of the earth. So stress is any force applied to strata. And we have compressional stress, which is that squeezing stress. And then we have tensional stress, which is that pulling apart stress. And then we have shear stress, which is those opposite directions. One goes up, one goes down. The big thing here, how is this different from tensional stress? Tension is pulling away in equal directions. Shear stress is pulling away in opposite directions, opposite horizontal directions. All right, so here's a picture I took when I was driving on the internet. And if we take a look here, there's this portion all the way here to the left, this darker layer here. And let's follow it to the right. Notice that it falls all the way down here. Then it jumps up. Then it falls down just a little bit. And it continues. But then it jumps all the way up over here. And then it falls all the way down over here where this person is. Why does that happen? That happens because stress was applied, which cracked up the rocks, and it caused the rocks to move and break up this way. This ultimately is what causes earthquakes, and we'll get into that in just a little bit. So how does all this happen? It happens because of deformation. So take out your notes, and let's go ahead and write down some vocab. Deformation. Deformation is a change in the original shape of strata. Again, strata is just layers of rocks. So here's some layers of rocks. And let's say we apply some stress, because deformation is caused by stress. And we bend these rock layers. That would be plastic deformation. That's a bending before breaking. Plastic deformation. That's a bending before breaking. Well, brittle deformation would be if we have that strata again, and instead of bending it, it breaks. It winds up splitting. So brittle deformation is a breaking of strata. So if we take a look at the glass here, the glass is definitely a brittle deformation. You all see me break glass in class before. And here we have the bending of glass due to this heat. And this would be a plastic deformation. Here we have a bending of a material. And here we have the breaking of material. Well, if this was strata, this would be brittle deformation. And this would be plastic deformation. The breaking versus the bending. Now, what are the conditions necessary for brittle deformation to happen? For right now, we're just going to concentrate on brittle deformation. We'll get into plastic deformation after finals. So for right now, let's talk about the conditions for brittle deformation, or where brittle deformation happens. Again, brittle deformation is breaking before bending. And this is going to happen close to the Earth's surface, way up top of the cold lithosphere. Why? Because temperatures here are colder. The Earth's strata is colder. If it were warmer, like this piece of glass underneath this flame here, it would bend before it breaks. But since it's cold, it'll break before it bends. So this happens in the shallow, cold lithosphere, very close to the Earth's surface. Just like this picture over here. This isn't deep within the Earth. Again, I took this picture while I was driving on the internet here, and if we're standing right here, we're standing right on the surface of the Earth, and we're taking this picture. Hello. We're taking this picture. Because we're standing at the Earth's surface, this is cold. Now, generally, this is going to happen at least underground a little bit, and then something will force this stuff to come up, but we'll get into that stuff later. All right, moving on. We have a couple more notes to take here. We're going to talk about fractures versus faults. Now, fractures. Fracture that is simply just a break in the strata. The big thing here is there's no movement. Just like this break in this dude's, looks like a knee, break in this dude's kneecap right here. Notice that we have this crack right here in the kneecap, and there's no movement of the bone forward, back, or side to side. That's a fracture. It's a fractured bone. If this was strata, we would call that a fracture. Now this guy here, he's got something a little different going on. Here's the bone, and there's a huge separation here. Same thing on the smaller bone over here. There's a huge separation between the bones because there was movement, and that's a fault. If this was strata, there'd be movement of strata along a fracture. So, for example, here is some strata. We apply some stress. Let's go ahead and say that we're applying some tension. We're pulling it all apart. And this is going to cause a crack in the strata to form. This right here would simply be a fracture. Now, if that stress continued and there was movement along that fracture, then that would be a fault, where the ground would move down or this piece of ground would have moved up. That would be a fault. All right, so let's take a little break. And let's watch this guy try out for American Ninja Warrior. He's running up this 16-foot wall here, and he's trying to stick it, but he can't make it. Gives it one more go. Boom. Makes it, hangs on, runs on down. Pretty cool. I challenge any of you to try to do this. It's not very easy. Well, what does this have to do with anything that we're talking about? Well, we have to know what the hanging wall and the footwall is. If we take a look at this guy training for American Ninja Warrior, and we take a look at this wall that he's running up, we see this incline here, this incline here that this guy is running up. This is called the footwall. Why is it called the footwall? Because it's something you can walk up. And notice that it has this positive inclination here, meaning that if this were a big piece of earth, it'd be a hill that you could walk up. Now here's this guy, and if we take a look at this wall here, and here's the big piece of earth, right here are the layers of earth, versus this guy here, these layers of earth. This is something that you would hang from. This is called the hanging wall. So here we have the footwall, and over here we have the hanging wall. And the best definition I have for these is that the hanging wall is that if you could hang from this big broken piece of strata, that would be the hanging wall. And if you could walk up it, that's the footwall. Now, you are going to see me abbreviate these a lot. HW for hanging wall, FW for footwall. Kind of obvious, but you should write it down anyway. Why is this hanging wall and footwall stuff important? Because the identification of the hanging wall and the footwall is going to allow us to identify the three types of ways that strata can move against one another. So to identify the three types of faults, we have to do a couple things. We have to identify where the fault is, or where the movement between the strata is occurring, and then we have to identify the hanging wall or the footwall. All right, so here's our fault. Here's the wall we could walk up, so this would be our footwall. Here's the wall we could hang from, so this would be our hanging wall. And if we'll notice, based on the railroad tracks, based on the layers, we could follow this guy right here, and it falls down here. It looks like the footwall moved up, or the hanging wall moved down. We can't really tell, but in this case, the footwall has definitely moved up, and the hanging wall looks like it has definitely moved down. Again, both may have happened. We don't know if the footwall actually moved up or the hanging wall actually moved down, or if both happened, but this is called a normal fault. And that's where the footwall moves up compared to the hanging wall. The opposite, here's our fault, right here. Here's our hanging wall, because it's the wall you can hang from. Here's our footwall, because it's the wall you could walk up. Notice that the footwall is below the hanging wall, or the hanging wall is up now compared to the footwall. So it looks like the hanging wall moved up, and it looks like the footwall moved down, and that's called a reverse fault. A reverse fault. And that's where the footwall moves down and the hanging wall moves up. So those are two of the three types of fault: normal fault and reverse fault. And in your notes, you should write these definitions down, and you should also try to draw a little picture. How do I draw a picture? Here's a normal fault. Real simple. Notice that we have a footwall. Here we have a hanging wall. The footwall looks like it's moved up. The hanging wall looks like it's moved down. Here's a reverse. Here we have a hanging wall. Here we have a footwall. Notice that the footwall looks like it's moved down, and the hanging wall looks like it's moved up. So here you have pictures to draw and your definitions. And the last one has two names. It's called a lateral or a strike slip fault. They both mean the same exact thing. And it's where the hanging wall and the footwall slide past one another horizontally. Meaning, it's where one wall does this and the other wall does this. There's no up or down motion here. So the railroad tracks got split horizontally. The road got split horizontally. This is very common in California along the San Andreas Fault. Do we know if this piece of earth moved this way or if this piece of earth moved this way? We don't. It doesn't matter. We just know that they moved horizontally compared to one another. And if I were to draw this, I would simply draw a couple of boxes that do this. And I would draw maybe a little river to show that the river got split. Or if you wanted to, you could draw railroad tracks to show they got split and show this opposite horizontal movement. Alright, so in this video, we talked about why we're talking about what we're talking about. We talked about the three types of stress. Talked about what brittle deformation is. Talked about fractures and faults. You should be able to identify a hanging wall versus a footwall, and what the three types of faults are. We'll review this material tomorrow in class, but if you have any questions before then, please feel free to email me or send me a message on Edmodo.